Well, hi everyone. My name is Naor Kalbo. I'm the R&D Security Research Manager at a cybersecurity company named Forescout. I'm based in Tel Aviv, Israel. Very excited to be here, first time in London. I've been researching the IoT domains for years now, and starting from academia, smart home, and a vast other industry experience. In my last job, current job, we are trying to develop new methodologies and new algorithms in order to identify better, in order to assess better, well, in order to defend better. So today I want to share with you some of our latest IoT risk research. And let me start with a story. So I'm a huge fan of Top Gun movies. And lately I watched the last Top Gun Maverick movie. And besides the fact that this movie is just fantastic, as a researcher, it really got me thinking. It really got me thinking from a defensive point of view. How the airplane, radar, human operator could best prioritize what enemy aircraft on his screen should be treated first. And if you are asking yourself, why the hell we should prioritize? Well, the answer is very simple. As a defenders, our starting point always starts with disadvantage. So this is a classical prioritization problem. What enemy aircraft pose the highest risk and should be treated first. So how can we prioritize? By the aircraft speed, by the aircraft size, by its altitude, maybe a clusters of aircraft, maybe even proximity to sensitive area. Well, honestly, I had no idea. But one thing was clear. We need to have some data. We need to have some data in order to learn better, to understand better, to assess better, to automate better, and enforce better. Well, we are all in endless run for data. I think we are all agree on that. And yet, data is not the goal, rather the mean. So how can we leverage all the data, knowledge, insights that we have gathered? So let's go back to Top Gun leading actor. And this time, in our case, it will not be Tom Cruise, rather than the F-18, Super Hornet. Well, now let's pour all the data that we potentially collected from OSINT, intelligence, any other source of knowledge. Well, first of all, we know that the F-18 Super Hornet's main functionality is a fighter aircraft. Well, this is pretty valuable, right? Secondly, we can learn about its configuration. We can understand that this device, this aircraft essentially, has one or two pilots, its length, its wingspan, how many engines, what is the maximum speed, carrier capabilities, and potential weapon system. Lastly, we received some indication that this specific aircraft was observed previously as a key fighter in many operations. Well, now, the dot or the icon on our radar screen has much wider context. And back to the question, how can we prioritize? So let me introduce you how the knowledge could be mapped into a structural framework. Well, let's start with the first section, the first pillar. We can ask ourselves what the device is, the functional factors. In our case, what is the aircraft role? Whether it's a commercial passenger aircraft, a fighter aircraft, patrol aircraft, they all means differently, right? Even the aircraft role within the squadron means something. Secondly, what a device has. It's basically a knowledge that defines the device's current status. And usually, a change is possible. Configuration factors could be something like what weapon systems are currently installed, or even what is the fuel status, how many crew members include, and what is its physical condition if we receive some indication about that one. And lastly, what the device does. Its knowledge about its activities, time series factors. In that manner, we can understand what is the weapon usage, flying altitude and speed. So the behavioral aspect essentially completes the pillar, but the risk actually resides in the intersection of all them. So let's drill down a bit And now instead of speaking about factors, let's speak about factors observation. So now you can see the three pillars, what the device is, what the device has, and what the device does. The functional, configuration, and behavioral pillar. Well, on the functional pillar, we know that the F-18 is a fighter aircraft, right? By the way, I don't know if you know that, but the F-18 could also be used as an airborne fuel tanker. True story. Secondly, on this specific device, we understand that the asset, the aircraft, has 4 air-to-air missiles, no air-to-surface missile. Left wing is slightly armed, and 2 crew members included. Lastly, we understand that the aircraft air-fueled 20 minutes ago and launched air-to-air missile at a drone 15 minutes ago. So, we got it. Functional, configurational, behavioral. But how can we assess the risk? So, by NIST definition, risk is a function of 2 main things. The first one is the adverse impact that will arise, and the second one is the likelihood. So in order to calculate the risk of asset X, we can simply multiply the impact by the factor's likelihood. So if this is the framework that we just talked, our framework built in order to support that definition. So now we are actually separating between the functional and the 2 other pillars, whereas the functional pillar will act as the impact assessor. It's kind of normalization factor. It could lower and increase the bar according to the knowledge that we know about the device impact. Secondly, each pillar in the configurational and the behavioral aspect will include factors. Each factors should tackle and address a specific factor's characteristic, specific factor's challenges, and they can weight differently. Lastly, we will add the multiplication operator between both of them in order to quantify the risk. So, with all due respect to Top Gun F-18, what other asset does the framework support and actually designed for? So the answer is very simple. Every connected device could leverage this framework. Where on the functional side, we will try to assess the device importance and criticality. On the configurational side, we will try to assess its attack surface, vulnerabilities, default password, exposed services. On the behavioral side, we will try to assess the network traffic observation, its activities. So the OS IoT Top 10. We actually try to understand if it's possible to map the OS loophole, and even more than that, into the framework. So surprisingly or not, it was very trivial and straightforward. In the functional pillar, we have 2 main factors, asset criticality and asset acquaintance. The asset criticality is basically how much the asset is critical in terms of business to our company. How much its availability is important, confidentiality and integrity important. Does it contain any PII? Is it related to medical life support system? Secondly, the asset acquaintance. How much we are familiar with this device, how much we are monitoring and managing this device, this asset. On the configurational pillar, exposed network services. What services this device actually exposed? What is the known vulnerability that this device is vulnerable to? Missing patches and physical hardening status, default or weak credential in use, or even hardware, software, operating system, end of life or end of service. Lastly, on the behavioral side, we can take factors such as traffic reputation, IP, DNS, URL reputation. On the public, whereas public internet exposure could be one of them, a meaningful one. Network threats, insecure data transfer. They are all fit perfectly into the framework. So let's have a real IP camera example. We all received so many indications, so many observations from many of our security tools trying to assess something about this IP camera. Well, we understand that this is an IP camera. Well, surprisingly, It's not a trivial task to understand that. If we know that, we should leverage that. Secondly, Telnet and RTSP are open on this specific device. Device is public facing, meaning anyone on the internet can access my device, or try at least. Device is vulnerable to a certain CVE with a CVSS score of 7.8. The operating system was end of life. Default Telnet credential was in use. On the behavioral side, we understand the device received malicious inbound traffic. We identified as botnet infection attempt. And lastly, we observed that the device is performing a malicious DNS query. Let's try to apply our framework to this real use case. So very simply, we can understand that on the functional side, it's an IP camera. And each device in the network will have a different functionality or type in terms of its meaning. Configurational side, the telnet that was open, services, vulnerabilities, end-of-life indication, credentials, they are all in the configuration pillar. And lastly, the device was public-facing indication, suspicious DNS, and malicious outbound traffic was also fitted here perfectly. So the technical people here will basically ask themselves, am I missing something? And the answer is yes. So I just present that we have a framework that's built on pillars, and the pillars are built on factors, which the factors collects observation. So what we are still missing? We are actually missing the factor scoring. How can we actually quantify the observation that we have collected? So in order to do a proper factor scoring selection, we need to assume two main things. The first assumption is that we increase the risk using observation, negative observation, bad observation. Secondly, the framework implementer should have at least a proper domain knowledge. And for each factor that we would like to populate, to insert to the framework, we should ask ourselves the following. Does the observation count matter? If the observation count does not matter, a very simple step function could do the trick, where on the x-axis is the number of observation and the y-axis is actually the factor score. On a certain threshold, you can see that we are maximizing the score as a step function. The threshold could be configured, 1, 2, 5,000. If the observation count matter, we should ask ourselves, do I have some severity for each of my observations? If the answer is no, I need to ask myself, should I consider false positive? If I don't need to consider false positive, a very simple linear equation could do the trick. Because for each observation, we have the same marginal contribution. If we should consider false positive, then a simple exponential equation might do the trick. And why is that? Because we assume that there is a certain false positive probability that getting decreased as the observation accumulated. As follows, the score starts very low and increased exponentially as the false positive decreased. If our answer to the severity is yes, we do have severity, and then the observation count matter, again, do we need to consider false positive? If we don't need to consider false positive, a system of linear equation could do the trick, where each severity has its own representation, and only the highest severity could reach the maximum factor score. And lastly, if we need to consider false positive, the observation count matter, and we do have severity included, you can see here, or not, that we have a system of exponential graph with the same behavior as the simple one, but now a bit more complex. So what are my main takeaways for you? First of all, defensive risk prioritization is not trivial. Second of all, we suggest a framework built on 3 spotlights. First of all, functional, configurational, and behavioral, where the functional could be a normalization factor for the entire framework. And generally speaking, we are all seek data, and yet data utilization is not straightforward and should be according to the use case we are trying to solve. You just saw that each risk factor has its own unique behavior, challenges, and characteristics, and should be studied and solved accordingly to the use case for a specific factor. And lastly, from a research perspective, risk research cannot be static. It should evolve constantly on the fly, specific and exactly as the constantly changing attack landscape. Thank you.